Okay, so here we've got the first grid, okay? Vertical line through the middle, vertical line halfway between here and here. I got it too close over here. It should be equally spaced, could be improved. You do better than I do, okay? And then here, halfway between here and the middle, that looks good. This is about halfway. These look fairly good, okay? I give myself a C minus on this first on the vertical lines and a B plus on the horizontal lines. Okay. If you got the right number of lines in about the right place, that's an A plus. Okay. You're gonna get full credit in the quiz. Screw up one little thing, well, you're gonna lose a point. Okay, but it's not gonna be a big deal. But next time it's got to be perfect. So if you have any imperfection, you want to be sure to get that out. Make sure you get everything right, or you won't have what you need. All right, now, first curve we make. The one we make on this grid starts here, not here. Right? It starts where the lowest construction line meets the left edge. I'm going to write that in words. First of all, construction lines. Those are the dotted lines. Gonna move over here because it blocks the board less. Okay. Our first shape. We start at the left edge on the lowest construction line. Okay. Make a point. Then might be a little hard to read, so it's hard to write down here at the bottom of the board. Yeah, I've got a little thumb injury, but you make a point, then you go one right, one up, which is pretty much what a lot of people did. There's some instructions. They start here, you go one right, one up, one right, one up, one right, one up, one right, one up. I think most of you picked that up last time. Okay, so it's a simple rule. Now, I think most people did that rule right. There's always a tendency to start at the lower edge, and that doesn't work at all. That's a total violation of this wonderful shape. Okay, don't let that happen. Then you can draw a curve. Got it? I think most of you have to start with. Be sure you have all those details. Biggest mistake I see is people trying to start at the lower corner. Okay. So don't make that mistake. Okay, second one. Very similar to this grid, but we add a couple of lines. So I'm doing everything I did on the first grid. There's the fifth construction line down here. Pretty close to the lower edge. I probably made it closer than I needed to because I didn't do everything completely accurately, but you get the idea, okay? So I got to be 5 horizontal lines. We only have 4 here. Also, you're going to do this, where you go halfway from here to here. and halfway from here to here. Okay? There's the grid, and that's what I'm seeing in the majority of papers, almost all of them. Okay? Again, very pleased to see that. Okay. Now, on this one, start upper left. Go one right and two down until you hit the red dot. Now, there's no red dot, but there's automatically a red dot. I didn't need it over here, but we want to put it there because it's the most important point on the grid, even if it isn't on most of the graphs. It'll be on this one, okay? So we start in the upper right. Oh, I said up, yeah, start upper left. And one right, two down. One right, two down. One right, two down. And that's why we drew the extra line here so we could skip. Okay? Keeping the rule as simple as possible. One right, two down until you hit the red dot. If I didn't have that fifth line in there, after this one, I couldn't go two lines down. Okay? Because there'd only be one line below me. We want to keep the rule as simple as possible. Then one up. Sorry, one right. Two up. To the upper right-hand corner. So we go one right, two up, one right, two up, one right, two up. And there we have our points. Okay. Now I saw some curves that kind of looked like this, but they didn't have the right points. Okay, so that's fine for today because you weren't required to know how to do these curves today. So it was a good attempt, but make sure you have it precise. Make sure you've got all these points where they belong. Okay. You get a nice smooth parabola. And if it can't be drawn on a grid like this, it ain't a parabola. Okay? Any parabola should be drawn on such a grid. We haven't put a scale on it. And we'll do a little bit with a scale here today. Okay. Got it? There's your rule. Okay. And I'll put those rules on the assignment page, just as I've written them or very close. Okay. So you always have them for reference. So if you couldn't read my handwriting, you'll see the details. But again, the rule here is on this one, start at the lowest construction line, left edge, one right, one up. End up at the upper right-hand corner. Here, start at the upper left. If you've got all the lines, you're going to be able to do this. If you don't have all the lines right, you won't. Okay. If you don't have all the lines pretty well spaced, you're going to get a distorted shape. They'll still be usable, but you won't be as accurate. Okay. Start upper left, one right, two down, one right, two down, one right, two down. That puts you at the red dot. Then you go one right, two up, one right, two up, one right, two up. Okay. Pretty simple. You just have to get it straight and don't confuse one with the other. Now the third grid. middle, halfway from the right to the middle, halfway from the left to the middle, halfway from each of those lines to the middle. There you've got your vertical lines, okay? Horizontal lines, middle. Halfway, okay, then that puts this line halfway from the upper edge to the lower edge. Then you go halfway from that line to the lower edge. I'm sorry, I don't want to say it that way. I'm doing this one. Okay. The way you think of this line is halfway from the lower edge to the middle. And then halfway from the upper edge to the middle. Comes out the same no matter what, but you want to be consistent in the definition. Then halfway from each of those lines to the middle. So every line you make here is focused on the middle. Just like it was with the vertical lines, you're always moving toward the middle. Whereas with these graphs, you're always moving halfway to the lower edge. Okay? Make sense? Okay, then your rule is a little more complicated because I got to use more words to tell you where to start. Okay? So start on the left edge. Construction line. Just below the middle. And then one right, one down until you're at the lower edge. Okay? So left edge, the construction line just below the middle. Here's the middle. Here's the construction line below the middle, just below the middle. Closest construction line to the middle, and there's your point. Okay? I'll draw the rest of the points in a minute, but I'll tell you where to start. The other half of this graph. And I said you start on the upper edge of the construction line just to the right of the middle. Okay, so here's the middle. Here's the construction line. Then one right, one down until you get to the right edge. Okay? So let's do the movement. Starting at this point, that's on the left edge. We go one right, one down until we hit the lower edge. And it doesn't take long. We go one right, one down. We go one right, one down, and there we are at the lower edge. And as I said last time, you don't cross the middle. Because if you wanted to extend this process, you draw another line halfway from here to the middle. And a line below this one that's twice as far from the middle. And you'd have a point here, okay? Then you move twice as close to the middle again, and a line twice that far from the middle, which would be down here. Okay? And after 10 steps, you probably hit oil. Okay? this thing goes down very fast. You call it asymptotic to the y-axis. That's terminology I would hope you've heard, but maybe you haven't. And we'll talk about it when it gets important. Okay? It just means we keep getting closer and closer to this middle line, but we never get there. And there's no limit to how far down we go. Okay? Doesn't take all that many steps to get out to the edge of the galaxy. 30 steps might get us there, 40. Okay? Because we keep doubling our distance and that builds up really fast, exponentially, which of course is what this is. Notice that everything doubles. This is from the lower edge, doubles, 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 right? Just throw that away. You don't have to make a note of it. We'll talk about it. Okay. This whole doubling and halving thing is kind of central to the way I've set all this up. Okay? Because it's the easiest way to get a grid for a graph and to get a pretty uniform grid. Okay? And it lends itself to the behavior of these functions. Okay, so anyhow, now we do the other half. We start at the upper edge, just to the right of the middle. That's this point. 1 over 1 down. 1 over 1 down, and we're done there. And then we connect these and we connect these, and we do not try to connect the left to the right because the left never gets to the middle. And if you move in from the right, it never gets to the middle, same way. Just keep going twice as high and twice as close. You never get there. And there's no limit to how high. And those are really important statements. So you kind of want to ponder them a little bit if you can. Okay. So I'm going to ask you to do that in the quiz next time. Okay? Because we want to always have those graphs at hand. And many, many times during the course, I'll say, okay, make this graph or make that graph or make the other graph. Make sense? Now, a little bit about some of the things we can do with these shapes, and a little bit about functions. Okay, because these are graphs of functions. Matter of fact, they have names. And I guess I'm going to have you know what the names are. Okay? This is exponential. You've heard people say this thing increases exponentially. How many of you have heard that phrase? Okay. Most people that say that don't know what the bleep they're talking about. They don't know the difference between exponential and polynomial behavior, and there's a huge difference. And it's subtle. And people use exponential carelessly. Okay? Inappropriately. And I mean, even people, broadcasters. Okay? You should go on a national broadcasting major network and misuse exponential. That's really stupid. And they do it, both ends of the political spectrum and the middle. Okay? Because there's a lot of stupid out there. I don't know if you've noticed. Okay. Everywhere. Left to right. Okay. Start upper left to one right. Okay, this one is quadratic or squaring. I'll use squaring, but I'll also use quadratic. How many of you have seen the quadratic formula? Are you familiar with that terminology, right? Okay. How many of you remember the quadratic formula? I don't know if I mentioned last time, but I went to pretty high level school of technology. And everybody there is in the top 10% of their class, mostly top 4 or 5%. Okay. And SATs, mostly above 1400. Okay. 2/3 of them didn't remember the quadratic formula. Okay. I was a little astounded. I don't know. Okay, anyhow. So if you didn't remember the quadratic formula, you're just as good as the people at that fairly exclusive institution, right? So you feel proud. Okay, for not remembering the quadratic formula. Okay. You'd be a little prouder if you could remember. This one is reciprocal. So starting next time, if I say at the outset, construct the graphs of the exponential, squaring, or quadratic, either word I want to use, and reciprocal shapes, and label them as such, you'll know what word to put on each one. Fair enough? It's not difficult. Just make sure you focus enough to do that. Okay. So good start. Yeah, I was going to talk about a couple of the ways these things correspond to reality. Thanksgiving is already passed, but I'm sure everybody's looking forward to next Thanksgiving when everybody eats a turkey, right? When everybody gets their own turkey and eats the whole thing, right? Whatever. You're supposed to eat a lot of Thanksgiving. Okay. So if you do, I'm going to draw a couple of shapes. Okay, where this is time, and this is temperature. Okay. And you can do the same thing. And I'm going to say that here's room temperature. And here's the temperature of the turkey when it comes out of the oven. Make sense? Okay. So what I want you to do is draw me a graph of what the temperature of the turkey does after it, when you take it out of the oven. Okay? What it does for the next couple of hours. Okay, so the graph, just to give you that, graph. Might look like this, probably not. Okay, we probably reject that one. Because among other things, at this time here, the turkey would have 3 different temperatures. Okay. And that would be, it's probably true if you measure the temperature at 3 different points in the turkey, right? If we're measuring it at just 1 point, have a thermometer in there, leave it there. We're not going to get a multiple valued curve. Okay. And I'll say that this is not likely. Not, there's only one temperature at any time. Not 3. Not 2. Is there a place where there'd be 4? Yeah, 2, 10. I don't know if there's any place where there, we see a place where there'd be 4 temperatures. You kind of get close here. If this little section came a little further over here, you'd have 4, right? But I think, I don't know, no, yeah, it actually looks like if I do vertical line, yeah, there's one with 4. Okay. Now, the reason I say that, oh, doggone this thing. Out of focus. Did I go out of focus? Did the board go out of focus? Why did the camera choose to go out of focus? Now it's in focus again. As soon as you insult it, it starts behaving. Okay. I don't like to use that strategy with people with cameras. It's pretty good. Okay. You don't do much positive when you insult people, even if they deserve it. Okay. Sometimes a little physical violence is okay. Well, I'm past the stage. Boy, I won't even think about that. Okay. There's a point to this. Okay. Temperature in this case would not be a function of time. Because if temperature is a function of time, there can only be one temperature for every time. And we know from reality that that's going to be the case with the turkey as long as we use only one thermometer in one place. Okay? Make sense? So, and that's your basic definition of a function. There's an abstract definition you'll read it. Okay, let's see. Here. Okay. So that's not a likely curve. How about this? That seem likely? Does it seem possible? Yeah, but you probably have to be varying the room temperature. Your room would probably have to be hotter than your oven for the thing to go up like this, right? Hotter than the initial oven temperature, okay? And that's not going to happen. Turkey's not going to get hotter than what it's surrounded by. It's not going to get colder than what it's surrounded by either. But we're assuming a constant room temperature. So that's not likely. Okay. Well, can you draw me a line or curve that would show you what happens to the actual temperature? Just slap down a graph, show me what you think. I'm just curious to see what you do, so don't take more than 30 seconds to do it, and I'll kind of look around and see what I see. Okay. As I said, most are trying out taking data and seeing exactly how things cool off. You know, I've been doing physics most of my life, so I've done that. And what's actually going to happen is, okay, which is probably what the plurality of the graphs, maybe the majority of the graphs kind of look like. Now, if you drew a graph that looks like that, it's not unreasonable. If you probably haven't taken a physics course, probably didn't have a physical science course in middle school or high school that taught you much of anything, okay? At least about temperature. You might have concentrated on other things. I don't really necessarily think that's a terrible thing. I'd like to see a little more physical information about students that come out of our seminary schools. But there are a lot of things people do. Okay, so it doesn't look like this. And another thing is, a lot of people went on through the room temperature line, which means now the temperature of the turkey is lower than the room temperature. And that ain't going to happen. Okay. turkey's gonna come to room temperature or come very close to room temperature. It's not gonna go below room temperature unless the room temperature changes. If the room temperature is changing, you don't want to deal with this. Okay, you do it intuitively, but the mathematics gets really complicated. Okay. Okay. So you notice this one doesn't come below room temperature. Now, some people did draw a curve that had this shape, which just kept on going right below room temperature. Because of course, we've just drawn a curve that sort of does that. Haven't we? Okay, except you got to flip it around. Just flip it. And it goes down and it approaches this curve. If you follow this process and keep going 1 unit left and half as high, 1 unit left and half as high, you get the whole curve. And if you keep going right, 1 unit right, twice as high, 1 unit right, twice as high, pretty soon you're out of the atmosphere. Okay. 20 steps would take you 1 million of these. Okay. And that's a couple inches of 6 to a foot, so it'd take you up about 160,000 feet. Okay. Which is about 30 miles, so you're not quite in outer space, but you're gonna die. Okay, unless you got some source of pressurized oxygen. That's like 3 times as high as Mount Everest when people die. Okay. Can't survive at that height for long. Okay. That's just 20 steps of that graph right there. And you're 3 times as high as Mount Everest. Okay. 4 steps shouldn't take you all that high. It builds up really fast. All right. So anyhow, back to this. Yeah, that graph goes below room temperature, but if you just bring it up so it approaches room temperature, just the way that graph, if it was flipped around, approaches that lower edge. You got this. That's pretty much what the turkey does. But not really, because there's some evaporation involved. Okay. If it was a completely dry turkey, and of course that happens way too often, completely dry turkey with no evaporation, no outgassing or anything, you would tend to have a pretty good exponential curve. Okay. So if you're running a large food service, you want to actually make some observations and see how different things approach the temperature you want them to be when you serve it. Okay. There's a real practical application. And a really big food service that's trying to be as competitive as possible, we'll take that data and use these functions. Okay. They won't just say, well, chef says about 20 minutes. It might be pretty good if the chef's really good. Okay. But chefs are under time pressure and they don't always get to be as good as they can. So you want to do everything as efficiently as you can to stay competitive. All right. Anyhow, there's that one. There's another one, since we're talking about, businesses and stuff. How many of you are in a business related curriculum? How many of you don't know yet what curriculum you're in? Yeah, mostly in general studies or science. Okay. So whatever. Usually we get a lot of people in a business curriculum. Some of the business applications are pretty easy to understand, easier to understand than the science applications. So one of them is just this, and I'm not going to. Hey, you're selling something. So you just got one thing to sell. You're selling widgets, because that's what everybody sells. It's a standard economics term for things that you sell as widgets. Okay. How many of you have a widget? Okay. Sometimes those things have to be surgically removed. Okay. Now, seriously. So you're selling widgets in some kind of contraption. if you charge too much, nobody's going to buy them and you're not going to make any profit. Matter of fact, you're going to lose money because it costs money to make the things and have them available and market them and everything, right? So if you charge too much, your profit is going to go into the negative numbers because of course positive is up here and negative is down here. Everybody's familiar with that. Okay. If you don't charge enough, you're going to lose money. If you give them away for free, but it costs you money to make them and market them, et cetera, you're going to lose money. Okay. So over here, if you give them away for free, let's say there's what you're going to lose, right? Okay. Over here, at some point, you're going to get down to where you don't sell any, and again, you're going to lose whatever it takes to make it. Okay. Now there's some point in between here. You make a profit. Right here is the selling price. They call this profit. Threshold. Started to write an E there. Okay. Okay. And we could call this another profit threshold. So we have profit thresholds here where we break even. And that's actually kind of the official term for it, the break even point. Okay. I'm not going to teach you economics or business or anything because I don't know anything about it. I don't know mathematics to know stuff about it. I just never focused on it. Okay. Then there's a point where we have the maximum profit. Okay. So we tell me, here's selling price. Selling price is zero here. Here it gets higher and higher. Okay. At this point, nobody's buying. Okay. So tell me when to stop to find the selling price where we get the maximum profit. Can you do that? And as soon as you see it, just raise a finger or something. Careful which finger. Okay. Now, ready? Most of you didn't vote. I want everybody to vote. Okay. I'll move the chalk so my hand isn't hiding. Where should I stop to get the maximum selling price? Okay, well, everybody told me stop before we get to the break even. I'm about to lose. So I'm going to go again. So everybody's hand kind of went up at roughly the same time. Since I see a majority of hands, I'll stop. Fair enough? Yeah, you're done good. Right there at the peak. Okay. So this line is the line where you get the price for the maximum profit, right? So if you got a scale on this graph, you just read that point. Okay. What's that line tell you? We can talk about this. Let me just see if you have thought. Okay, well, I got a very quick answer and it was absolutely correct. It's the amount of your maximum profit, right? Because your profit is on this. Numbers on this correspond to profits, right? And when you're at this point, your profit is this much. Okay? And that's as high as it goes, according to the model. Now, if you're actually using this model, it's an approximate model because there are all kinds of market factors. You do research. You figure out how the demand is related to the selling price, right? Okay. And usually it goes something like this. Well, you make a guess, but based on what you hope is valid experience and good insight. Okay. And the better you are at the business, the better you're going to be able to predict this. Your first guess is, okay, if I give them away, that many people want one. Okay. If I sell at this price, nobody's dumb enough to buy that. Okay, it's not worth anywhere near that. Okay. Of course, you got some people that show off and buy things no matter what, so maybe the curve doesn't quite hit zero. But you start with a linear model, okay? It's a straight line graph, and it's not actually a straight line. You know it's not actually a straight line, but you know that you don't know exactly what's going to happen anyway, so that's your best guess. Now, maybe you have a market research team that can come up with a more complicated, more complex model. They know quite a bit of mathematics. If you've got a big business, you're going to hire somebody who really knows mathematics of marketing and selling and all the finance. Okay. If you're running a mom and pop business, hope you can draw a graph and have a little intuition about what works. Okay. And of course, then you probably know your customers better. And you can make good guesses. You probably don't need the mathematics, maybe. Okay, and every business is kind of somewhere in between that. I conjecture, if a business person comes along and tells me that's a bunch of BS, they might be right. But that's the mathematical model that you do teach people in business courses. Okay. And then you multiply the demand by the selling price, which tells you your revenue. Okay. And we'll do the mathematics of this. But the demand times selling price is going to look like this. Because this is a linear function, and when you multiply a linear function by this variable, you get a quadratic function, which gives you one of these squaring quadratic graphs. It's upside down, but it's the same graph that you're learning to construct, that you probably already know how to construct. Okay? So you want to get intimately familiar with these graphs in these shapes and the functions that they correspond to. Okay? So this would be revenue selling price, but I don't want to keep writing out the word. Okay? Does that make sense? Now, that's not your profit because it costs you something to make these things, right? So you also have your cost function, which has another graph. So your cost function might well be something like this. Here's your cost, here's your demand. Okay. And when I say revenue price, yeah, okay, we'll go with that. But then you add this function to this function, or you subtract this function from this function, you subtract your cost. And what's the interpretation of cost? It takes you this much to set up, get your business running, and then the more widgets you make, the more it's going to cost. Okay, it's not difficult to understand. Now, If you don't have any more interest in business than I did when I was your age, you know, it's not going to be a particularly inspiring model, but you have to understand that it's a significant application, and the mathematics is really quite easy to understand once we get about a month into the course. Okay, once we understand quadratic functions, quadratic formula, stuff like that. Okay, and you've seen it, you've used the quadratic formula, it's not hard. But the quadratic formula gives you a lot of information. The quadratic formula, once you get the equation for this function, which just involves x squared and x and just plain numbers, okay? Once you get this quadratic function, you can use the quadratic formula to figure out this place where the curve peaks. And you plug this value of, let's say, the selling price into that function, and it tells you what the profit's going to be. Okay? And you set the quadratic function equal to 0. And that's where we use the quadratic formula to find these 2 points. Okay? And it's really pretty easy if you've done everything you need to do up to that point to master it. Starting with being able to construct that stupid graph. Okay? Fair enough? All right, good. Okay. There are other applications. But those are 2 that are fairly easy to understand. Understanding all the details of how you put these functions together, you know, that's what we're going to build up for about the next month. Okay. All right. Now, there's another thing I want to do that I, with my infinite lack of foresight, didn't watch it above the board. Things been a little crazy this week. And I'm not making excuses. Didn't have to be crazy. You know, actually they did. Too many details. Okay. Now. Oh, yeah. One other thing. You know, I didn't tell you here. Let's just go back and correct that. I forgot. I knew I was doing it. I left myself room here at the bottom. The red dot goes at the center of this graph. I told you that last time. So you should have known it. I didn't check your graphs to see if you had the red dot in there. But it always needs to be in there. So next time, make sure it's there, okay? And I really don't have any, I was looking at other things that I wasn't looking for the red dot. Maybe because I didn't see it. I wasn't looking for it, so I don't know if I saw it or not. Okay. Now, to apply these functions, you need some numbers. Okay. So right now, we're just going to talk about numbers. We'll let X go this way and we'll let Y go that way. And I'm not going to draw a set of coordinate axes with an origin because we don't know where the heck this thing is. Okay. So I'm just going to say that here X equals 4. And here let's let X equal 12. Okay. So this vertical dotted line here for the left edge is where X equals 4. For the right edge, X equals 12. Horizontal line for the lower edge is at Y equals 8. And the upper edge is at Y equals 24. Okay. Now, I begin my construction. Every construction begins with a center line here, okay? So what's X equal here? Write that number down on your paper, somewhere prominent, put a big circle around it. You can also put it on your graph, but I want to be able to spot it quickly to see how you're doing with this. Okay, big, maybe top of the page, big number, big circle. What's X equal at that point? Now I'm going to circle at the top of the page, but I'll it's right. Okay. Okay. That's not the top of your page. I can see it. It's big. That's I think I see it. See, I don't want to have to search for it on your graph. Unless you got a really big graph and a really big prominent circle. Okay. That's the page a little bigger, but I see it. It's fine. It's right. Okay. No, I'm going to see it up there. Okay. I want to be able to see these quickly. If I have to search through your page to find it, I don't have time. Don't want to take class time to do that. Okay, so looks pretty good. Okay, now I just said people did pretty well because most people have the right number, which is gratifying. It's got to be between 4 and 12. She said negative 273. I forgot who did that, but somebody did. No, not really. Okay. So then you're a little disoriented with the numbers. Okay, that happens. But it turns out that halfway between 4 and 12, there are a couple of ways to figure this out. You could say, well, between 4 and 12, that's 8 units, because 12 minus 4 is 8, right? And halfway would be 4 units. So 4 units to the right of this would be 8. And 4 units to the left of this would be 8. So I'm pretty sure 8 is right. So X equals 8. Okay. Now you can do that intuitively. If these numbers were like 3,795 and 12,598, two of my favorite numbers, you'd probably have to calculate it, right? And how would you calculate it? You get the number in the middle, you just add them and divide by 2. Okay. Make sense? So you can always do that. But for these numbers, you ought to be able to, at least for these numbers, you ought to be able to kind of see it right away. Now for these numbers, you might not be able to visualize it as easily, but you can do it. You can count from 8 to 24. Start with 8, you got 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 3, 25, how many hands did I do that? 15 and 16. Okay. I don't have that many fingers, so I'm kind of lost. All right. And so there's 16 units between here and here. Of course, you could just subtract 8 from 24. If you do that in your head, not everybody's real good at mental arithmetic, but if you do that in your head, it's good. You get 16 and you divide that by 2, you get 8. So then you go 8 up from here and you get 16. And you go 8 down from here and you get 16. So you're pretty sure 8 is correct. Okay. Now, I didn't even ask, but that would be the middle line here. Either by some sort of common sense, right? Or by averaging. We find that that's 16. Okay. Now we continue the process. Okay, so what's this line? X equals what? What's this line? X equals what? What I want to see, you're going to want to do it in your graph, but I want two numbers in one circle at the top of your page. What's the first thing you've got to see in order to figure out what X is at this line? Well, everybody knows the construction. How was this line constructed? It was halfway between this one and this one, right? So we want a number that's halfway between 4 and 8. Well, that's easy. That's going to be 6. Okay. Makes sense. Okay. Now you can average it. So between 4 and 8, you probably don't need to write out 4 plus 8 divided by 2. Okay. If you do, that's fine though, because that's a good calculation. Nothing wrong with it. But pretty intuitive, the X would be 6 here. And similarly, X would be 10 here. And I think I saw everybody have 10. But again, from 8 to 12, halfway between 8 and 12 is 10. So yeah, 8 and 12. Sorry, 8 and 12 from your perspective, right? And then you have 9. You have 9 and 11. And then you go up one here, you have 10 and 10, and boy, there's a middle, right? Another way to look at it. You should be able to look at it every one of those ways, but you're going to have one way that's more intuitive to you than the other. Okay. Now we're doing this because I find that people generally have trouble doing this. Okay, shouldn't be. It shouldn't be that coming out of secondary education system, people don't have this orientation. It's because there's overuse of calculators and pictures and computers, and people don't have to do that. You can just bypass it, but it's easy intuition to gain. So, you know, if you're my age, you'd never figure it out, but you're young, your minds are flexible. Okay. Pretty much anybody. It's not as simple as I am could do it. Okay, so, and then we could do the same thing here. Now, let's say that we're doing the exponential graph. Now, there are going 3 numbers here. Can you figure out what these 3 numbers are? Think about the rule for constructing the lines, twice as close and all that stuff. Okay. Okay, let's start with this line. Where's that line? It's halfway from here to here. So what's halfway from 16 to 8? Okay, 12, right? Okay, because 16 and 8 is 24, divided by 2, you get 12. Or because you count 8 and 16, 9 and 15, 10 and 14, 11, 11 and 13, 12 and 12. There it is. Okay, that's the intuitive way to do it. And of course, you can't do that with big numbers. You have to write them out. Now you do that, 8 plus 16 divided by 2, halfway. The difficulty people have in answering this question frequently is just remembering that this is halfway between here and here. Okay. But of course, when you drew the pictures, you got the halfway thing. So you got to connect what you did in the picture with the numbers. Okay. Now then, this one is halfway between this and the lower edge, which means it's halfway between 12 and 8. That's pretty easy to see. Halfway between 12 and 8 is 10. And then this one is halfway between 8 and 10. Gee, what's halfway between 8 and 10? Okay. Well, that's y equals 9. I'll label it over here because it gets a little crowded over there. Make sense? So I'm probably going to ask you to do something like this with some numbers, and maybe some numbers that you need a calculator for. If you need a calculator for these numbers, it's okay. As long as you know how to, you know, but the main thing is understanding halfway. Okay. So. Also, of course, understand that there would be a red dye. There's a harder question I'm going to ask you probably for the quiz next time. I won't count it against you if you don't get it, but I want to see how many people do get it. Okay. So make sure you can sketch these graphs, and also I'm going to post an assignment for some simple algebra. Okay, just want to review some simple algebra, make sure everybody has the algebra they need when we get to the point where they move. All right. Okay. Very good. Have a great weekend.